Hello everyone, I hope you're all doing well. So in today's video, I'm actually going to go through the 2018 Specialist Maths Exam 2 for the Northern Hemisphere multiple choice section. Like always guys, before I start this video, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. Guys, if you haven't checked out a website, it'll be in the link in the description. You can find notes. We're selling notes very cheaply, and we're also selling some practice exam. And yeah, we have some tutoring packages. If you guys want to have a look at it, it'll be in the link in the description of this video. So yeah, let's smash through this exam. Question 1. Let f of x equal cosecant. The graph of f is transformed by, first, a dilation by a factor of 3 from the x-axis, followed by a translation of 1 unit horizontally to the right, followed by a dilation by a factor of a half from the y-axis. The rule of the transformed graph is a very nice typical question. So, okay, let's write f of x. This is originally our graph. Cosecant x. Here, the first thing that we're doing is a dilation by a factor of 3 from the x-axis, or we can call it parallel to the y-axis. So what we're doing is that 3, we're multiplying f of x by 3 pretty much. When we're dilating by a factor of 3 parallel to the x-axis or from the x-axis, what we're multiplying the whole f of x by 3. And that will be, oopsies, it will be 3 cosecant x. Alright, now, so we've done that, that's a tick. A translation of 1 unit to the horizontally to the right. So if we want to translate it 1 unit to the right, we're going to sub inside the function x minus 1. It means translating it 1 unit to the right. And that'll give us 3 cosecant x minus 1. Next one, a dilation by a factor of 2, by a factor of a half from the y-axis, or we call it parallel to the x-axis. So when we're putting it inside our function, it needs to be, what's the reciprocal of a half? It's 2. So imagine in the x, we're subbing 2x. Yeah, so we're dilating it parallel to the x-axis or from the y-axis. So it'll be 2x. Next one, 3 cosecant 2x minus 1. Which one does that look like? Looks like B is your answer. Nice. Question 2. Let's use a different color. So let f of x be this and g of x be this, where x is between 0 to pi over 2. If f of g of x is equal to what? Okay, so we want f of g of x. Alright, so inside f, we're subbing just tan. For all the values of x's, we're subbing tan squared. So tan squared x plus 1 all over tan squared x. You should know that this over here, if you use your formula sheet, you should see this property, this relation. 1 plus tan squared of x is actually just equal to secant squared of x. Here, 1 plus tan squared of x, as you can see, it's the same as this. Shouldn't we just sub in secant squared of x? So we're saying secant squared of x. Again, it's being, reciprocated, but, no, it's being square rooted, but we can get rid of that square root, and we can take that 2 out. So it'd just be secant of x, because we're just square rooting it anyway. All divided by tan squared of x. Okay, so what's happening? It's secant. So it's saying, what we're saying is secant x is being divided by tan squared of x, or I can just, we're timesing it by 1 over tan squared of x. Okay, now we know that tan of x is sine over, so sine x over cos x, but imagine squaring it, so it's sine squared of x divided by cos x, and we're reciprocating it, it'll be just cos squared of x over sine squared of x. Okay, and we know that secant is just 1 over cos, so we can rewrite that as 1 over cos of x, and we can get rid of this and that squared. Simplifying this to cos x sine squared x. Now, sine squared x, if you kind of reciprocate that, you can write it as cosecant squared of x, pretty much. And which one does that look like? It looks like D is your answer, that one. Look, sometimes you may get confused. Like, for example, let's say you're in the exam and you're like, oh my God, I'm trying to do all these calculations, but I'm not getting one of those answers. You know what you just do? Okay, think about it. If you were in the, let's make this smaller. Say you were in an exam and you're like, I don't know what to do, damn. This is what you do. What you can do is, let's go to our calculator and actually, let's write the function. So what we were saying is, we were saying that, if you have this, so in this case, it will be tan x this squared, and it's all squared, plus 1 all over this whole, so tan squared of x. So we get this, and because we know that, remember that x is between 0 to pi over 2, so that's some value that's between them, like x is equal to pi on 3. That's between them. Let's sub that in. Okay, we get 2 over 3. Now imagine that, because we know that f of g of x is one of those. So let's start subbing. Let's try a. So if we sub it, so sine of x times, you know, sec, so secant, we need to multiply that, secant this squared, given x is that. Is it going to give me the same result? No, absolutely not. Let's try the next one. This is what you can do if you don't know what to do. Like in an exam and you get a question like this and it's too hard, it's always better to be safe using your CAS than to be like, you know, missing out on a question like this. It's very easy by doing this. And yeah, you can just try all of those out, trial and error, and you should get, you know, one of those right, at least. Yeah. So this, and it's all squared, and you get 6. So yeah, but if you put like the one that we just did, which was cos of x, so cos of x times cosecant, well, it's right over here, cosecant, which is this, of x all squared. What do we get? We get 2 over 3, same as this. So that's what you can do. Just trial and error, quick method. Yeah, that's it. Question 3. The implied domain of the function with the rule f of x, this is what? Okay, wow. Now, I'm going to just, okay, we'll slowly do this question, how to approach it by hand. You can easily do this by CAS. You know, you can graph it and you can just do that. But let's say this is a kind of a great question they could put in exam 1 because it really applies how you think about the domain and range in a way. So let's understand what's happening. So we have f of x and we want to find the implied domain of this whole function. So can we see, do we know that when we have a function like f of x over g of x, we know that the domain is always g of x. It's like all reals with the exception of when we solve g of x for equals 0. Pretty much that's our actual equation. So for example, when does, you know, g of x equals 0, let's say it's 1, we'll just write all exception of 1 because we know that the denominator cannot be equal to 0. So, okay, having that, have a look at this. So we have something, a function divided by a function. And we know that the denominator cannot be equal to 0. So this pi over 2 minus, I'm going to write it as cos inverse, make, you know, 2 minus x, can only, we don't want it to pretty much equal to 0. That's our goal. If it equals to, so yeah. So what values of x does this, you know, not equal 0? Well, let's try. If I was sketching this by hand, well, you can easily sketch this by hand. Think about it. So we know that if I was sketching a cos, just a basic cos graph, let's say this is exam 1. So a basic cos graph goes like this, and it's a nice graph like this, and we know that this here is pi on 2, this over here, this point over here is pi, and this is -1 to 1. Yep. And so what's happened is it's reflected along the x-axis. So what's going to happen is, imagine this is going to be like this, and it's going to be like this. Now that's our graph, and I'm just going to rub the next, this, oops. I'm going to rub those out. There's no need for that. Yeah, so, okay, and that's, and then what's also happened is, it's been translated 2 units to the right. So imagine translating 2 units to the right, it will pretty much look like over here. So it will be over here, and it will look like this. Where this here is 3. This point is 3 now. And this here is 2, okay? And still this is pi. And what's happened, we've done that, and then it's reflected along the y-axis. So imagine this like this. It's reflected along the y-axis. So now this is negative pi here. Let's rub those out, these ones over here. We don't need those to not confuse ourselves. And then the last thing is it's been translated pi over 2 units to up. Now we know that this here is negative pi over 2, and this here is negative pi. And imagine translating negative pi over 2 units to the up. It will look like this. This is your final graph. If I just take yellow, and so it would be, this part will be here, and it will look like this, and it will look like this, pretty much. And we can rub those out. We don't need any more of this, because this is our new graph. And we know that, okay, now let's think about this. What we want is, okay, let's have a look at the domain. Remember, we want the values of x, of this part over here. What values of x can we take? That will give us, so what we're pretty much saying is, what values of x will give us everything but except, equal and 0. What? So, for example, let's try to look like, this over here. 1. Well, we know the graph starts at 1, so 1 is included. Great. It gives us a great value. It's not equal to 0, so we start from 1. We try all those values. Great, it's not equal to 0. Until we hit 2, that's a problem. So when we hit 2, so if we sub in 2 over here, what happens? It's actually equal to 0, and then it gets, what happens when it's equal to 0? Then it doesn't exist. So we would say from 1 to 2, non-included. Union 2, and then we can continue. So all these values are great because they're not actually equal to 0. They just go below, and until this part over here, which is 3. There we go. So this over here is actually your domain. By using your understanding of everything, you can actually find the domain like that. Say it was an exam one. I just want to show you guys how to understand how to find these, and yeah, which one would that be? Will be this. What about, for exam, let's say 2, you have your cas. The quickest way, the quickest way, just use a cas. For example, if you're using a TN-SPI, you can just write domain. It means the implied domain of the whole function. And let's write the whole function. So 3x over pi over 2 minus cos 2 minus x, comma x. And here it is. So pretty much saying from 1 to 3, except 2. Same thing. That's it. Nice and easy. Next question. On the Argand diagram shown above, 4c's negative 2 pi over 3 is represented by what? Okay, so 4c's. Now we know that 4 over here is what? It's your radius. So we're saying the radius is 4, and your angle, your argument angle, is negative 2 pi on 3, which is negative, just make it to basically negative 120 degrees Celsius, like degrees, it did not Celsius, degrees. Yeah, so if I was drawing this, where is it? So we know that there is a radius at 4. So imagine drawing a circle with a center of 0, and we know it has a radius of 4, so I'm just going to draw a circle. Let's draw this, and I'm just going to draw these points going through those. Like this. Like that. Okay, nicely putting those in. Perfect, and this is the circle, and so we've got the radius, and so it lies in any point inside this circle, but it has to be negative 120 degrees. So we start from here 0 and we go below. So negative 100. So this is negative 90 here degrees. So negative pi over 2, and negative 120 is plus negative 30, which is approximately over here. Done. That here is another overall from here to here. That's negative 120 degrees, and yeah. This is the point, S. It touches the, that's where our radius is, and it is, that's the angle, so it's actually S. That's the point, it touches. So S is your thing. Or you can, if you're just too confused, what you can do is, you can just go into your calculator and make this into the Cartesian form, and just kind of do it. For example, let's do that in our calculator. So what we can do is write it. So you can write this as 4 times, in terms of polar form, e to the power of, write the angle. So, for example, this is negative 2 pi over 3. And we're going to multiply by I, the angle, always. We enter, and guess what? We get it in a nice form, in Cartesian form, and you can just, it's the same point as S. So yeah, that's how you can do that. Question 5. Which of the following graphs shows the set of points in the complex plane specified by the relation these? Okay, nice and easy. well, you can use your calculator. So if we let z equal x plus y on, we can solve it. For example, let's do that. So if I know that z plus 2, let's write this whole thing. And we know that conjugate of z, so go menu, number, complex number 2, so complex conjugate of z is actually just equal, so plus 2, all it is equal to 4, given that we want z to be x plus yi. We want you to do that, enter, and we get this, and we want to complete the square. Go on algebra, complete the square of this whole function over here, comma x, comma y. And we get this beautiful equation. So let's write that down. So we have x plus 2 squared plus y squared equals 4. So what is our center point? Like, what's our coordinates? It's -2, 0. And what is our radius? It's the square root of that, which is 2. So our radius is 2, and that point is the center. So which one does that look like? Yes, the center is here. So -2, 0, and the radius is 2. So this looks like B is your answer for that one. Nice. Question 6. Given that z minus 3i is a factor of p of z, okay, which of the following statement is false? Okay, I just had a look over here. Always when you get a a complex polynomial, always look, are the constants real values? They're not, like, they don't have I. They don't have any value complex like I. If they're like this, these are all real numbers, what we can say is the complex conjugate root theorem actually works here. What is the complex conjugate root theorem? What it's saying is, given that this is a factor, it means this is a solution, z equals 3i, there has to be, the complex conjugate must also be the solution. So for example, the complex conjugate of this, which is -3i, must also be a solution to this whole equation. So that's great. So let's check which one's false. So it's saying when we sub in p3i, it's equal to 0. That's absolutely true, because that's a root. Also, this one also, because we know that the complex conjugate also works, is also a root. P of z has 3 linear factors over the complex plane. Well, let's check that. So we can rewrite, kind of factorize, nicely factorize this how. So I want to make an equation with these. So what I can do is I can write it as z squared minus alpha plus beta, z plus alpha beta equals 0. So what is this? This is actually a notation. For example, our alphas are our roots. For example, the first root we have is 3i, and our beta, in this case, is -3i. We have 2 roots, and okay, the first one is adding them together. So adding them together, we get 0, so just z squared. What about timesing together? Alpha times beta, so we get pretty much -3, so negative, and I squared plus 9. This is our actual, if we expand these, the factors of that, we'll get this quickly. And yeah, so making this equation, we know that there has to be a z, because when we times z squared times z, we get z to the power 3. And what about this over here? Plus 2, because then when this is 9 times 2, it should be 18. So we get this. So what can we see? A little bit, simplifying that, so we get z minus 3i, z plus 3i, z plus 2. What do we know? P of z has 3 linear factors. Yes, they are all linear, as we can see that z is to the power of 1. Factors over the complex plane. Absolutely, they are. Yeah, complex, it's inside the complex plane. All of them are inside the complex regions. That's great. P of z has no real roots. Rubbish. We do have a real root here. So D is wrong. Remember, a real root is like, it doesn't have I. It could be like -2, -3i, or no, -3, -3i. Now this here is a problem because it has I. That is a complex. That's not real. That's part of the complex. So it's only these are real. So things that don't have I pretty much are real. So if E is the one that's false, it's pretty much D. Let's check E also. P of z has 2 complex conjugate roots. Absolutely, we've just showed that. So that's true. Question 7. The gradient of the line that is perpendicular to the graph of the relation this at the point of this. Very nice, easy question. So use implicit differentiation to differentiate that. Let's do that. So this, differentiate that in terms of what? So it'll be 6y. Because we differentiate it in terms of y, we're going to have to multiply by dy dx. Here we're going to have to use the product rule. So if that -5x is your u and your v is y, So using a product rule, so it'll be first negative 5x. Derive y, which is just 1, but it's in terms of y, so we have to multiply by dy dx. Plus y, then derive negative 5x, which is just negative 5. And then, the other one's just negative 2x, and then derive 1, which is 0, it's a constant. And then if we sub in this point, and we solve for dy dx, let's do that. So if we sub in, so it'll be 12y dy dx, minus 5 dy dx, minus 10, minus 2 equals 0. This overall becomes 7 dy dx, 12, so hence dy dx is 12 over 7. Now we want that perpendicular, so we have to use the normal. So imagine this is m, 12 over 7, and we want the perpendicular line, which is going to be negative 1 over m, which is negative 7 over 12, which is D is the answer for that one. Nice and easy. Oopsies. Let's make this short. Next question. Let's use a different color. Next question. Question 8. Using a suitable substitution for this, okay, can be expressed as well. Okay, so well, let's let u be 4x plus 1. Hence, then dx will be what? It'll be 1 over, what's the derivative of the function, which is just 4, multiplied by du. So if I was rewriting this integral, these terminals have to be in terms of u. So like when x is equal to 1, we'll sub it in here and get what? What's your u? So you sub in x equals 1, it'll be u is 5, so it'll be 5 at this point here. If I sub in 2 into x here, it'll be 9, okay? So 3 over 2. Now we know 4x plus 1 is just equal to u, so it'll be plus u squared. And dx is equal to that, which is 1 over 4 du. Nice. We can take that one, like the constant, this and 1 over 4 outside the terminal. So 3 over 4, 5 to 9, 1 over 2 plus u squared du, which will be 3 over 4, 5 to 9, 1 over 2 u squared du. Looks like B is your answer for that one. Nice. Question 9. 1 minus cos 10x dx is equivalent to what? And so we can see the answers are in terms of like 5. So they've probably used the double angle formula for this. Now, what's the double angle? So if I was, let's really simplify this. So 1 minus cos 10x, yeah? This cos 10x, if you use the double angle formula, you should know it's also it's in your formula sheet. It's pretty much this. So it's cos 2x is equal to 2 cos squared of x minus 1. So in this case, we're considering that this over here is just cos 10x, and it's equal to 2 cos squared 5x minus 1. Okay, and we can sub this into our cos 10x. So, right, this is 1 minus, so cos 10x, which is equal to that. So sub that in. 2 cos squared 5x minus 1. 1 minus 2 cos squared 5x plus 1, which is just 2 minus 2 cos squared 5x. Okay, so if we integrate that, 2 minus, we can take that 2 out. So it'll be 1 minus cos squared 5x dx, which doesn't look like any of the answer. We can actually simplify this because we know that the property cos squared x plus sine squared x is actually equal to 1. Hence, like bringing cos squared x here, it's just equal to sine squared x. So overall, this whole expression, 2 integral, is equal to sine squared 5x dx, which is what? Looks like easy answer for that one. Nice. Question 10. The graph of the antiderivative of the function of g is shown. So this is your antiderivative. Which of a formula could best represent the graph of g? So we want to derive this. Okay, let's have a look at its slope. What can we see about its slope? Well, it's always increasing, so it's always positive, like plus, positive, 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 positive. It's always positive. So it means that in the dy dx, so it must be above the x-axis. So this one's below. As you can see, it's below. This one's great because it's on top. That's good. This one's here, it's below. That's a problem. Here's below. So it could be E or C. And what can we see the difference between them? Well, B has like the slope equaling to 0, which, let's understand this. Let's have a look at this. Does the slope equal 0? Well, if I was having a look at this, it's actually not equal to 0, because if you like, it's still at this point, it's actually not a straight line. It's like, it's greater, it's a positive slope. If it was, it would have looked like pretty much it would have looked like this. If I was drawing, it would look like this, where this point over here is like a straight line, whereas here it's kind of bent. So we know that the derivative should not equal to 0. So your y, for the next one, shouldn't be this, because it's actually equal to 0. That's wrong. It could only be E. And you can see that E doesn't actually touch the y-axis. No, it doesn't touch. So when x equals 0, we know that imagine this is dy dx. It's greater than 0, as we can see. So that's great. Easy answer for that one. Question 11. Let A be this vector and B be this vector. The acute angle between A and B is what? Very nice and typical question. You just have to use this rule. So we know that the dot product of A and B times the magnitudes, so A dot B, times cos theta, where theta is the angle between them, the acute angle. And when we can do this, we can easily do this by calculator. So let's do it. If I define A as the vector, which is 2, negative 2, 1, oops, negative 2, 1, and B as a vector, which is 2, 3, 6, we know that, okay, we know that the dot product, so go to vectors, we know that the dot product of A and B should equal to the magnitude of A, which is norm of A, times the magnitude of B, which is norm of B, times the cos theta, which is your angle between, oops, cos O, which we call it theta. Anytime we get this, and we can solve answer comma O, given that we know theta is an acute angle, which is from 0 to pi over 3, so O to pi over 2, sorry, pi over 2, because it's an acute angle, that equals what? It gives us this, which is in radians. So what I'm going to do is take this angle and multiply it by 180 over pi to change it to degrees, which gives us 79 degrees. Done. Just choose C as your answer. Alright, next question. Question 12. In the diagram above, LOM is a diameter of the circle with the center O. Okay. N is a point on the circumference of the circle. Great. If R is ON, so O from here to N, so this here is R. So it's the R vector. And S is MN. So S, let me nicely do another color. This here is MN, which is S. Then LN is what? So we want LN. So from here to this, what is this? Okay, for LN, so for LN, the vector LN, what do we know? We know that it's the addition, we can get it from the addition of LO plus ON, which is R. So let's do that. It's the addition of LO vector plus R, which is from O to N. Now, LO is what? We know LO is this. Now, because it is the radius of the circle, and we know that the radius is equal to this over here. So if this vector we want, it's actually equal to this vector, because we know the magnitude is the same, and we just need to find the direction, which we still put the same from O to M. So in other words, what we're saying is that, this is what we're saying. L to O vector is actually just equal to O to M vector. So what is O to M? How do we get O to M? To get O to M, it's going to be R plus N to M, which is just negative S. So it will be O to M is going to be R vector minus S vector, pretty much. Yep. And now we have O to M, which is just equal to LO. We just sub it in there. So L to N, which is what we want to find, it's just R minus S plus R, which is just 2R minus S. 2R minus S, which looks like easy answer for that one. Nice. I hope that was easy to understand. Let me just bring this over here. Wow, it's actually, why isn't it struggling to move? Wow, okay, wow. That's certainly quite annoying. Ah, gotta keep it there. I'll just keep it. Question 13. So let I and J be, let's use a different color. Let's use this. Let I and J be unit vectors in the east and north directions respectively. At time t is greater than 0, the position of a particle A is given by this, and the position of particle B is given by this. Particle A will be directly east of particle B when t equals what? So wait. Particle A will be directly east of B when t is what? So if B is here, for example, let's say particle B is here. A has to be directly east, so this direction. Sorry. They need to be directly east, so A has to be direct, so this has to be directly east, which in this case, this is what we want, of B. So yeah, particle A will be directly east of particle B. Great, so that's what we want. So, and we want to find the times at which that is true. Well, okay, let's say if particle B is here, and particle A is here. What do we know? We need the J components, this because the J is the north and the south. That's what the J component is. It's the vertical. We need the J components to be equal. So it means that if they are equal, they could be here. They're always equal. Even though the distance could be like from here to here, and this is A or B, the distance are still, they are directly, it could be east or west, but they are at least this, directly, next to each other, and that's what we want. Remember, we want them to be pretty much close to each other. So what we want is the J components to be equal. So we want this J component, so 5t minus 8, to be equal to this J component over here, t squared minus t. And we can use our calculator. Let's use our calculator. I'm not going to solve that. We don't want to make errors, especially it's the second we can use the CAS calculator. Minus t. We can solve answer comma t. So we get t equals 2 and 4. Let's write those down. T equals t and t equals 4. Now, okay, we want to check if some could be wrong, some could be right, because there's two solutions. So let's think. What about if we, let's say, for example, what if we do is sub in t equals 2? Let's check that. T equals 2. If I sub it in here, what do we get? So for the I component, if I sub in t equals 2, it'll be 4 minus 10 plus 6, which is 0. So your x coordinate is 0. What about the y coordinate? If I sub in 2 here, it'll be 2. So if I was, that's A. So A, so you just put A here, and the coordinate is, put it on top, so 0, 2. That's what coordinate it is. What about the next one? What about B? Where's B at t equals 2? So B would be 1. And if I sub in 2 here, 2 squared is 4. Minus 2, which is 2. 1, 2. Okay, so it would be to the right here. And this would be 1, 2. So remember, the 2 is they're both at the same, like, J component, like, yeah. But they, B is 1 unit to the right. Which is wrong. Remember, we want A to be directly east of B. Can you see? So B has to be on the left and A has to be to the right. Whereas this one here is A is to the left and B is to the right. So, yeah, that's... So t equals 2 is wrong. Let's try the other one. What about t equals 4? So if I sub in t equals 4 to A, to find where the position is. So 4 so 16 minus 20 plus 6, which is 22 minus 20, which is 2. So it will be 2. And if I sub in 4 into this, it will be 20 minus 8, which is 12. So let's say this is A. This has to be 212. Now let's check where the B part is. So like B. Okay, B is when t equals 4. What does it happen? So it'll be -1. It'll be -1. And if I sub in 4, so it's 16 minus 4, 12. So it'll be -1, 12. So it'll be over here. B. And there'll be -1 over 12. So it'll be over here. Okay, that's great because B is on the left and A is to the right. And that means that A will be directly east to B. So t equals 4 is correct. So only t equals 4 pretty much. Hope that makes sense. Question 14. The diagram below shows a particle at O in equilibrium. So when in equilibrium, we know that the net force is 0. In a plan under the action of 3 forces of magnitudes P, Q, and R. Okay? So for the magnitudes, P and Q and R, which of the following statement is false? Let's check the first one. R is equal to Q sine 60. So what we're saying is the magnitude of R, which is this, is equal to Q sine 60. Well, okay, if I was breaking those down, like, if I break this down, and if I break this down, we know that this here, we know this part here is, if I know that's 90 degrees here, 150 minus 90, so it has to be 60 degrees. And this one, because the addition of these must be 180, and this is x here, so it'll be 30 degrees pretty much. Okay, and this is how the arrows are going to look. What do we know? So because we know the net force in the J direction, so the vertical direction, must be 0. So R, this one, should equal this vector plus this vector, because they're both going up. So R is equal to P sine 30 degrees plus Q sine 60. That's what it should be. Which here it's just saying Q sine 60, which is wrong. It has to have P sine 30. That is wrong. So that's the false one from what I know. Well, let's check the other ones. Q is equal to R sine 60. So the Q here is equal to R sine 60. That's actually hard to do here. But guess what we can do? We can use a property here, actually. Lami's theorem, because we have 3 forces. Let's use Lami's theorem. So what Lami's theorem says is, for example, the force P, so we put P, divided by the sine of the angle. So so if P's here, the angle over here, which is 150 in this case. And now for Q, it should be equal to Q. So Q, what's the angle in here? So what's the angle? It is so 120. So yeah, so sine 120. And R, let's try R2. What's R? R is, if R is over here, the opposite is just 90 degrees, which is sine 90 degrees, which is 1, which is just R. Okay, so that is what we have. So if we want to show that R, this is true, Q equals R sine thing, we're just going to equate these two here first. So R is equal to Q sine 120 degrees. Okay, let's think. 120 degrees, we can just write it as sine of 60 degrees. Because it's 180, so 180 minus 120, which is 60, and it's in the second quadrant, which sine is positive. So we get this, and then bring this over here, hence Q is just equal to R sine 6 degrees. Which is true, so that's true. That's great. That's true. What about C? Let's try C. So C is saying that P is equal to R sine 30. So they're making these equals, pretty much. Let's make them equal. So P is equal to sine 150 is the same as 30 degrees, and it's positive, is equal to Q sine 120. Again, we said it was 60 degrees. And you want to see that... Oh, no. P is equal to R. Sorry. So is equal to r. We have to put r. So yeah, it is. So hence P is just r sine 30. That's true. Also, next one is they're making Q and P equate. So we're going to use these over here. So we can say that is just P sine 60 is equal to Q sine 30. Okay. And we know that we're using cos here. And you should know that, okay, think of it. So in terms of this is P, what's sine 60 degree, which is sine pi over 3? It's just root 3 over 2. What is sine 30, which is sine pi over 6, which is just a half? Let's check if that's true for this. Q, what's cos 60? Cos 60 is saying, we're saying cos pi over 3, which is a half. So Q, in this case, we're just saying Q is a half, is equal to P, and cos 30 degrees is root 3 over 2. Can you see how they're both equal in the statement? So Q is a half, Q is a half, P is root 3. So they're actually, in other words, we've just, yeah, also D is correct, because that's pretty much, yeah, equal. Next one, P equal, so P is equal to cos 60 plus Q, so they're, okay. And that's all equal to R. Okay, let's come back to our equation here. Let's rub this whole thing now. We don't need it. Come to this back equation when R is equal to this. Remember how we said, so P is sine 30, so what's sine 30, which is sine pi over 6? It's half. Plus Q, this one, sine 60 is just root 3 over 2. Let's check if that's equal to that. So cos 60, which is cos pi over 3, which is a half, so P is a half here. Plus Q, this is cos 30 is root 3 over 2, it's equal to R, which is what we've just said. So also is right. So the only one is A is wrong. I hope that makes sense. Question 50. A 80 kilogram person stands in an elevator that is accelerating downwards at 1.2. The reaction force of the elevator floor on the person in newtons is what? So let's draw a diagram. So what we're going to get is we're going to get something like this. Let's say this object is a person, and we know that he's going to have 80 G's of force of gravity. And we're also going to have a reaction force, N, of the elevator floor on him. And because we know the elevator is going down, acceleration is going down, we're going to take this as positive. So like the net force, we're going to take the downwards as positive. So it's going to be, if we're adding these two vectors up, it'll be 80 G minus N must equal to the mass times the acceleration. Well, in our case, our acceleration is just, we said it's 1.2. So just using our calculator and solve for N. Let's do that. So we have 80 G is 9.8 is equal to minus N is equal to 80 times 1.2. And we just will solve answer, comma N. So N is equal to 688. Choose A as your answer. Next question. Question 16. A body of mass 2 kg is moving in a straight line with a constant velocity when an external force of 8 newtons is applied in the direction of motion for t seconds. If the body experiences a change in momentum, so change in momentum is impulse of 40 kilograms per meters per second, then t is equal to what? Now, what do we know? We know, if you do physics, this question is like a drinking water for you. It's very easy. We know that the change in momentum, which is just impulse, is equal to mass times v minus u, so your final velocity minus your initial velocity, which is your change in momentum. Or also it's equal to the force times time. Well, in this case, we are trying to find time. So we know the change in momentum, which is I. We can just make force is equal to Ft pretty much. If we know the change in momentum is 40, and we know the force is 8 newtons, and we're finding time is just 40 divided by 8, which is 5 seconds. So only C is your answer. That is the quickest way if you use your physics formulas. Great. Question 17. A object travels in a straight line relative to an origin O. At time t seconds, its velocity meters per second is given by this. Okay, so this is your velocity over time. The object will be back at its initial position when t is equal to us. Okay, if you do physics, again, this is quite an easy question for you. So what it was saying is, Okay, let's think. We start at O. Let's say this is position O. And this is a velocity time graph. So what can we see? Remember, the area is your displacement. For the first, so let's look at it. So for the first 4 seconds, what do we see? We can see that the area is positive, meaning that let's take the positive direction as north in this case. So what's happening is, okay, imagine a person starts at O and he starts going for the first 4 seconds walking, because this is the area is positive, so he's walking at some distance. So let's say he's walking up until here. That is here is time equals 4 seconds now. And guess what's happening? His velocity becomes 0. It means he stops at t equals 4. And what happens is now his whole thing, his displacement is becoming negative. It means that he's going now south. Remember? Now he's going south. Imagine now he's turned direction and starts going south. And what can we see? We can see that the area is bigger than the north one. Means that he's going further down. Like, for example, he's going down to here. Which here is from 4 to 10 seconds. So from here, this whole thing here is pretty much time is, this is the 6 second, distance he's walked. And the questions we're asking is, okay, let's look at the question. The object will be back at its initial position when t equals what? So if this is his initial position, well, he was walking, he'll be back over here. And we want to find the time at, find that time where that position is. And that's easy because we know that the area here should be equal to this area over here. Like some area over here at some time. If we know that this area should be equal to this area, we can find this value of t at which the initial position equals 0. In other words, what we're saying is when this displacement, so when this displacement, so the area under here should equal should be when it's added to this, it should equal to 0. That's what we're saying. So, but we'll make our life easier in calculations. What we're going to just say is this area should equal to this area over here. Let's do that. Okay, I hope that makes kind of sense. So, yeah. So we're saying the area of the first part, which is this over here, which is this given here. So from 0 to 4. Now, it's above the x-axis, which makes our life easier. So we can just 4 minus t minus 2 squared dt. And that overall should equal, let's put it over here, should equal from 4 to some value of, let's call it x, some value of t, at which the area here should equal to this area. Because we're making both areas equal, so I'm going to make this positive area, so I'm going to put a negative. I'm going to multiply a negative with this, so it'll just become positive, so it'll be just square root of 9 minus t minus 7 squared dt. And yeah, let's use our calculator and solve for x. That's the time. So 0 to 4, the square root of 4 minus t minus, t minus 2 squared dt should equal to 4 to the value of x, where square root 9 minus t minus 7 squared dt. And that gives us, oops, and we solve for x actually, wait. We solve for x. So solve, answer, this whole thing over here. Not answer actually, just take this overall, comma x. Control enter, we get the time. So x is equal to 6.7, which is C as your answer for that one. Nice. Question 18. The height of all 6-year-old children in a given population are normally distributed with a mean of height of random sample of 144. So your n value here is just, so let's write a different color. So we know our n value, we know 144 6-year-olds children from the population is found to be this. That's your mean. So if this is your mean, so your sample mean here is just 115, we're saying. That the mean height of random 140 children from this population is found to be 115. If a 95% confidence interval for the mean height of all 6-year-old children is calculated to be this, the standard deviation used in this calculation is what? Okay, just use your standard deviation formula. We know it's equal to, we're only going to use one part of it, because we know it's equal to x minus because we're using 95, it's going to be 1.96. It'll be S over root n. For example, our n value is 144, so it'll be just 12 and the square root of that. And that overall should equal to this part over here. 113.8. And we know our mean, we can take that out. Our mean in this case is just 115. And we solve for S, which is your standard deviation. Very nice and typical question, to be honest. Let's do that. 115 is equal, sorry, minus 1.96 S over 12 is equal to 113.8, and we solve answer comma S. And hence S is 7.35. So B is your answer for that one. Nice and easy. Question 19. A local supermarket sells apples in bags that have negligible mass. So the bags don't have any mass. The stated mass of a bag of apples is 1 kilo. The mass of this particular type of apple is normally to be distributed with the mean of this and a standard deviation of this. So the mass of a type of apple, let's call it, okay. So A is apple, so the expected value of an apple we're saying is 105 grams. And the standard deviation of an apple is 7 grams. A particular bag contains 9 randomly selected apples. So a bag has 9 apples. So what we can say is a bag has 9, which is just like apple plus apple plus apple plus blah 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 to 9, pretty much. When you're dealing with probability, please don't make the mistake of writing like close to like 9a. This is, be careful. So you don't want to write like b is equal to 9a, because this is kind of dangerous, because when you find a variance, you'll get your answer wrong. Make sure to write them like this: a plus a plus a dot dot dot. This is, we're gonna explain why actually, because the questions asked, let's understand the probability that the 9 apples, so probably that the 9 apples in the bag, so let's say bag, have a total mass that is less than 1 kilo. Less than 1 kilo, which is 1,000 grams, is what? Okay, we need to find then the expected value of B to do that. Well, the expected value of B is just like, expected value A plus the expected value A till 9, which is just overall 9 of expected value of A. 9, easy, which is what's 9 times 115? So 9 times 115 is 1035. So let's write that down. 1035. Now let's calculate the variance. So the variance of B is what? Remember, we're doing this, so it's going to be like, equal to the variance of A plus the variance of B till pretty much, which will just become overall 9. Let's move this a little bit to this way. It will just become 9 of variance of B. If we said it was like 9a, remember that case when we were saying if a lot of students will just write B is equal to 9a. This is the problem. When you find the variance, you're finding the variance of 9a then, which from the formula, it's going to be squared. The constant gets squared, so it's 81 variance of A. And that's wrong. Be careful. That's how they can trick you, so don't make that mistake. Make sure, think of it like this. So we get that. So, sorry, this is supposed to be A here. So it's 9 times the variance of A. Okay, let's do that. So 9 times, well, the standard deviation is just, so the variance is just 7 squared, which is 441. And then just square rooting it. Wait, I want to make sure if I got that right. So first 7 squared, which is this, and then we times it by 9. We get this, and then we take the square root of it. And we get 21. So in other words, we found the standard deviation of B, which is 21. Great. So now we can just do our calculation. So go on menu, go on probability, go distributions, normal CDF. So we're going from negative infinity to 100,000, sorry. Your mean value is 1035, and your expected value is 21. Answer that, and we get this. So which one does that look like? 0.047. Looks like A is your answer for that one. Nice. Last question. A farm grows oranges and lemons. The oranges have a mean of this and a standard deviation of this, and lemons have a mean of this and a standard deviation of this. So let's write that down. So the expected value of oranges is 200. your pretty much your standard deviation of oranges is 5, and your expected value of lemons 70. Your standard deviation of lemons is equal to 3. Great. Assuming masses for each type of fruit are normally distributed, what is the probability? So probability to correct 4 decimal places that a randomly selected orange will have at least 3 times the mass of a randomly selected lemon. So wait. That a randomly selected orange, so orange, will have at least, so greater or equal, 3 times the mass of a selected lemon. So 3 times L. And we want to find that. Okay, so what we can do is, we'll bring that 3L back from the inequality, like backwards here. So it'll be O minus 3L greater or equal to 0. Now this is much suitable to do. So we just need to find the expected value and the variance of this over here. So what we want is the expected value of O minus 3L, which is just the expected value of O minus 3 expected value of L. So what's the expected value of O, which is just 200, minus 3 times the expected value of a lemon, so this. So 7, 14, 21, we know that's 210, hence negative 10. That's the expected value of that. What is your variance of O minus 3L? It's going to be the variance of O plus, because we get, that negative 3 gets squared, so it'll be 9 variance of L. Your oranges is what? The variance of it is just 5 squared, which is 25, plus 9. What's the variance of the lemons? It's just 9 when you square that. So we get 25 plus 81. And now we can just use our calculator. So what is 25 plus 81? And then we're taking the square root of it. It's this. Control Enter, we get this. Great. Now we can actually just use our calculator. Now go on menu, go on probability distributions, normal CDF. We're going from, so it's greater than 0, so 0 to infinity. So we know I know the standard deviation is this, and our mean, we said it's negative 10. Press OK. Doesn't work. Let me try it again. So this has to be 0, infinity. That's that. And here is negative 10. Press OK, and we get this, which is negative, so 0.16. C as your answer. Nice. I hope you guys learned something through this video. And yeah, guys, make sure to please like and subscribe for more future videos. Thank you so much, and have a great day. Bye-bye.